This is integration quiz number 1, so let's work this one out. So we're going to use u substitution. So if that's u, then du would be negative 3 dx. Okay, so if we do our substitution, u gets that piece. So we got 1 over u du. Now du is going to replace the dx. And we got this negative 3, so remember we divide by negative 3. And if I need to speak in more detail about that, please let me know. So when you integrate 1 over u, you get ln x, right? Well, there's another little thing that we have to be aware of. It's actually ln absolute value x, because the natural log or log of a negative number does not exist. So we want ln absolute value x as the integral of 1 over x. But since we're dealing with u here, 1 over u, the integral would be ln absolute value of u. And don't forget this negative 1/3 sitting out here. So there's the integral. And then we want to undo that substitution. Put the 5 minus 3x back in. And we're going to evaluate at 4 and 2. Okay? So when we plug the 4 in, we get negative 7. But remember that absolute value. And I'm going to come up here to the top and finish this up. So we got ln negative 7, but absolute value would be ln 7. Minus, plug the 2 in, we get ln negative 1. But absolute value, because we can't do negatives of logarithms. So we would have ln 1, which is 0. So we got ln 7. And when you throw this negative 1/3 in there, you'll get the first choice, A. Because ln 7 times a negative 1/3 would just be that answer there. So it matches A. Okay? And I wish there was just a clear button. If you know where the clear button is, please let me know so I don't have to erase this every time. So let me know if I need to add any more detail to that problem or not. And the other one was number 4. Let me take that line off. Oh, I guess I can't take that line off. Okay, so just zoom in here, see what's going on with number 4. I don't know why that red line's there. Okay, so we want the derivative of this integral. So we said when you're doing the derivative of an integral, the shortcut would be just replace whatever's up here with the variable there. So I would have ln, replace t with 2x. Now if I could do a little example up here. Okay, so if I want I'll just make up something short. So if I'm taking the derivative of this integral and I have just an x, I can replace x into that equation and just get x to the 3rd. But in the problem that you're doing, you have a 2x. Okay, so you think chain rule here. I plug in the 2x into the integral, but then I have to multiply by the derivative of that. See, if you go back up to my little example I did up here at the top, the derivative of x is just 1. So that's why the answer just stays x to the 3rd. But in this new problem, we plug in the 2x times the derivative of the 2x, which is 2. So kind of think that chain rule situation there. And then distribute your 3. And that might have been the part that was messing you up. You had to multiply by the derivative of that top bound of the integral. So we get 8x to the 3rd plus 1 times 2. And you can certainly bring that 2 to the front and get that answer, the second choice. So So let me know if that was helpful or if I need to go back and explain any of these other skills. Both of these questions had underlying skills. So if we need to talk more about those, please let me know. Also, if you'd like to have a Zoom meeting, let me know a good day and time that we could do that, and I'll send a link, and we could do that one day if it's needed, if we need to talk face-to-face about anything. And I'll end the video now.